Imagine you built something so incredible, so perfectly engineered, that it's still working after nearly 50 years. Not in a lab, not on Earth, but 15 billion miles away in the absolute void of space, beyond everything we've ever explored. Now imagine that thing is dying, slowly, and the only people who can save it are a team of engineers who have to send commands that take 23 hours just to reach it. This is the true story of Voyager 1, and why what happens next matters more than you think. In 1977, NASA launched 2 spacecraft with a simple mission: fly by Jupiter and Saturn, take some pictures, and come home. Except they never came home. Instead, they kept going, and going, and going. 49 years later, Voyager 1 is still sending data back to Earth. It's the farthest human-made object in existence. It's crossed the heliopause, that invisible boundary where our sun's influence ends and true interstellar space begins. It's literally the only thing humanity has ever sent to the edge of our cosmic neighbourhood. Every single year, Voyager 1 loses about 4 watts of electricity. That might not sound like much, but when you're running on a plutonium battery that's been decaying for nearly 5 decades, every watt counts. The spacecraft was never designed to last this long. The engineers who built it are mostly retired now. Some have passed away. But their creation, still working, still exploring, still sending back data from a place no human being will ever reach. Until recently, that is. On February 27th, 2026, something unexpected happened. During a routine maneuver, just a simple roll to reorient the spacecraft, Voyager 1's power levels dropped in a way nobody predicted. The engineers back at NASA's Jet Propulsion Laboratory in Pasadena, California, immediately understood what this meant. They were running out of time. The spacecraft has what's called an undervoltage fault protection system. It's a safety mechanism. If power gets too low, the system automatically shuts down non-essential components to keep the probe alive. It's like your phone going into low power mode, except if it triggers, it could take weeks or months for the team to bring systems back online. And in space, every day of downtime is a day you might not get back. So the team faced a choice. Let the automatic system take over and risk losing Voyager 1 for an extended period, or make the decision themselves about what to shut down. They chose to act first. The Low Energy Charge Particle Instrument, or LECP, has been the eyes and ears of Voyager 1 since launch. It measures ions, electrons, and cosmic rays. It's detected pressure fronts in the interstellar medium. It's revealed the structure of space itself in ways we never could have imagined from Earth. Think about that for a second. This one instrument has fundamentally changed our understanding of the universe, and now, to keep the spacecraft alive, they had to turn it off. While shutting down a science instrument is not anybody's preference, said Kareem Badruddin, the Voyager mission manager. It is the best option available. Best option, not good option. Best option. That's the language of people who are making impossible choices. But here's what makes this decision even more remarkable. It wasn't made in a panic. Years ago, we're talking a decade or more, the science and engineering teams sat down together and literally planned out the order in which they would shut down instruments. They knew this day would come. They prepared for it. They had a list. The LECP was next on that list. What strikes me most about this story isn't the crisis. It's the foresight. It's the fact that people in the 1970s built something so robust, so well engineered, that it's still functional nearly 50 years later. And it's the fact that the people running the mission today are so thoughtful about keeping it alive. When they shut down the LECP, they didn't completely kill it. They left one small motor running, a motor that spins the sensor in a circle to scan in all directions. It uses half a watt of power, half a watt. That's almost nothing. But by keeping it running, they're leaving the door open. If they find extra power somewhere down the line, They might be able to turn the LECP back on. That's not just engineering, that's hope. The shutdown command itself is a journey. It takes 23 hours to reach Voyager 1, then it takes another 3 hours and 15 minutes to execute. So from the moment the team presses send, it's more than a day before they even know if it worked. But this shutdown is just a temporary measure. The real plan, the thing the team is working on right now, is something they call the Big Bang. And yes, that's actually what they call it. The Big Bang is a coordinated power swap. The team will turn off a whole group of powered devices at once and replace them with lower power alternatives. It's a massive undertaking, it's risky. If something goes wrong, they could lose the spacecraft entirely. So they're testing it first on Voyager 2, which has slightly more power to spare and is a little closer to Earth. Tests are scheduled for May and June of 2026. If those work, they'll attempt the same fix on Voyager 1 sometime in July. And if the Big Bang works, there's even a chance they could turn the LECP back on. Think about the audacity of that. Think about the confidence it takes to plan a major surgery on a spacecraft 15 billion miles away, knowing that if something goes wrong, you can't send a repair crew. You can't go get it. You can only watch and hope. Here's what I think people miss about Voyager 1. It's not just a spacecraft. It's a message. It's humanity saying, we were here, we looked around, we tried to understand. The Voyager Golden records, the ones attached to both spacecraft, contain sounds and images from Earth, music, greetings in 55 languages, the sound of a kiss, a baby's cry. They're time capsules, really. Messages to whoever or whatever might find them millions of years from now, but Voyager 1 is also a message to us. It's a message about what we're capable of when we plan carefully, when we think long-term, when we build things to last. It's a message about the importance of curiosity and exploration, even when there's no immediate payoff. The engineers who built Voyager 1 are mostly gone now, but their work lives on, and the people keeping it alive today, the team at JPL, the mission managers, the engineers who are planning the Big Bang, they're not just maintaining a spacecraft, they're maintaining a legacy. They're keeping humanity's greatest exploration mission alive. Voyager 1 is still sending back data from a region of space no other human-made craft has ever explored. No other spacecraft will reach that region for decades, maybe centuries. If Voyager 1 dies, we lose that window. We lose the chance to understand what's out there. And yes, I know what you're thinking. It's just one spacecraft. We have other missions. We have other ways to explore space. But that's not the point. The point is that Voyager 1 is there. It's working. It's sending back data. And as long as there's a chance to keep it alive, there's a reason to try. The team has about a year of breathing room now that the LECP is shut down. They're going to use that time to implement the Big Bang. They're going to try something ambitious and risky because the alternative, letting Voyager 1 die, is unacceptable. In a few months, we'll know if the Big Bang worked. We'll know if Voyager 1 will continue its journey into the unknown, or if this is the beginning of the end. But either way, what Voyager 1 has already accomplished is extraordinary. It's travelled farther than any human creation ever will. It's explored space that no one else has ever seen. It's sent back data that's changed our understanding of the universe. And it's done all of that while being maintained by a team of people who care deeply about keeping it alive, who plan carefully, who think about the future, who leave a motor running on half a watt of power just in case they might need it someday. That's the real story of Voyager 1. Not just a spacecraft running out of power, but a testament to human ingenuity, foresight, and the endless drive to explore. The light at the edge of everything is still shining. And as long as there's power to keep it going, the people at JPL will keep it burning.